about Cashu blinding Bitcoin custodians, I understand. Let's get you set up here. So the state of Lightning is interesting because when I go to the supermarket in Panama, we have these kids packing their bags, and I always tip them with Lightning. So, like they have like 20 kids there, and everybody has a Moon wallet now. So maybe that's the idea if you want to tip some kids there. All right, Calle.
Hey. Oh, here
Lighting.
we are.
Okay, setting up your thing here. Perfect. Calle, stage is yours. Shady
Thanks a lot.
Supercar, Calle, please.
So good morning, everyone. Thanks for coming. Thanks for the organizers for setting up this amazing event. Also for all the volunteers here. I was asked to speak slowly so that the translators have a chance to catch up. So I'll try my best. My name is Calle. I'm a developer. I work on LM-Bits and other projects on the Lightning space. My newest project is called Cashu that I want to present here. And thanks already for Adam's talk in the morning. He mentioned Chaumian eCash. I want to talk about how Chaumian eCash can be used to blind Bitcoin custodians today. So let's start with a very basic question. Why Cashu? What is Cashu? So we live in a world where there are many custodial services in Bitcoin. They provide some sort of value to the users, most of which I think also has to do with the transaction capabilities, the challenges that we face on a blockchain, that also directly translate to challenges on Lightning, right? Like opening and closing channels, for example. So the problem with any custodial service or almost any custodial service today is that a custodian knows exactly how much you have, who you're transacting with. So you're a completely transparent user, and that harms your privacy, but also opens up ways for censorship. So we have a solution for that, and the solution is that instead of using a ledger to store all user transactions, we propose to use the magic of Chaumian eCash and blind signatures. So these are two words that will try to explain during this presentation. It will be a kind of technical presentation, so I hope you'll all be with me. If you drop out at any moment, please bear in mind everything that I'm trying to explain here is to improve privacy of custodial services. So there's already a couple of projects in the Cashu ecosystem, so to speak. There are 3 independent projects. There is a wallet and a Mint implementation in Python that is kind of like the reference implementation for now, which is a standalone application and a library that you can include. There is a Go Mint and wallet that is cross-compatible with the Python one, completely independently developed. And there's a JavaScript frontend that we're working on, something that I'm going to present more about at the end of this presentation. What is also very important to me is to build this into some kind of protocol. So we're also working on a spec such that other developers have easier time to implement their own Cashu integrations. Chaumian eCash. So what is Chaumian eCash? I will try to explain it so we're all on the same page. But first of all, it would make sense to talk about classical custodianship. So what I'm going to show you here, I think applies to almost all custodial services that people use. So that might be a wallet of Satoshi. It could be a Kraken account. It could be even your bank account at your fiat bank, right? So we have 3 actors on stage, Alice, Bob, and Carol. Alice and Carol are both Bitcoin users. Bob is the custodian, sometimes called the bank, sometimes called the mint. So Alice wants to send 1 BTC to Carol. What usually happens is that first Alice pings the bank and says, hey, I want to send some Bitcoin. The bank pops up a database and then checks the following things. It checks, first of all, do these 2 people have an account? And if that's the case, does Alice have enough money to send? And if that's the case, it will subtract 1 BTC from Alice's balance, add 1 BTC to Carol's balance, then ping Carol, and Carol will notice, yep, my balance just increased. So this is an ordinary transaction on almost any custodial service out there. Behind the curtains, what actually happens is that, you know, when the bank makes sure that there's enough balance, then it will take out this list of all transactions where you have all the past transactions of all users and then add 2 new ones. So subtracting from one user, adding to another user. So this is necessary basically in order to make sure that there is no inflation in the system. So to keep the integrity of the ledger, you need to know the state of the ledger. So you need to know what everyone has. Now Chaumian eCash works a little bit differently. We have again the same 3 actors on the stage. Now Alice wants to send 1 Bitcoin to Carol. Instead of now talking to the bank before, Alice talks directly to Carol and says, hey, I have this token, this money token here. This is eCash. So here it is represented also as a string that we have also seen in Adam's talk before. But think of it as a piece of data that you load from your database, from your hard drive. So it is literally stored on your computer, not on a server. So you load this piece of data and you send it through over any means. So that could be a Telegram chat, email, or whatnot. Send it over to Carol. Now, transaction is not complete yet. This token could be double spent. So you could send the same token to another person as well. In order to prevent that, Carol needs to redeem this token for a new token with the same value with the mint. So Carol talks to the mint, sends it over, and now the mint asks the following questions. Did I ever see this token before? If not, then did I sign this token and is the signature valid? If yes, then destroy this token, generate a new one, send it over to Carol. Now the transaction is complete. So we've sent 1 BTC from Alice to Carol by generating a new token in between. Again, looking what's happening behind the curtains. So when Bob receives this token from Carol, it asks, have I seen this token before? Pops up a list again with all the past seen tokens that Bob has encountered during its lifetime and adds it to the list. This is what happens instead of checking balances, etc. So then generates a new token, sends it over to Carol. The crucial difference to what we've seen before here is that this new token that was just generated, the green one, is not you cannot correlate it to the pink one that was minted before. So that means if you now take an eCash token, you do something with it, you send it around, and then you come back to the mint and say, hey, I want to redeem this token. The mint doesn't know which one it corresponds to when it first was created. That gives you the privacy, basically. This is the mechanism that makes it possible to send around money without anyone knowing what's going on. So the way this is all solved is through a cryptographic scheme called blind signatures. I'm going to try to explain what this means. Blind signatures, here's the definition. Blind signatures are a way to sign a message that you have never seen before and to be able to verify your signature once that message is revealed to you. So a very nice way, I think, to think about this, an example out of the physical world is carbon paper. So carbon paper, to be on the same page, is the paper where you write on top of it, for example, when you fill a form, and it produces the same kind of writing on the paper below it, right? So it presses through. So imagine you have a contract that says, I own 1 BTC. You put that normal paper, as a normal contract, you put that contract into an envelope made out of this carbon paper, right? So you take your 1 BTC contract, put it into this envelope, you close the envelope, and you send it now to the bank. The bank takes out a pen and signs the outside of that envelope without opening it. Then sends you the signed envelope back, and you open now the envelope, and what you see is a signature of the bank on the document that the bank has never seen. That makes sense, I hope. And crucially also, if you now present this document to the bank later, they will be able to verify, yep, this is actually my signature, everything is okay. Now obviously, we're not doing it with paper, we're doing it with cryptography, so here's how it works. We have Alice and Bob. Alice now generates this random string. This is a random number, you could think, or random string. Puts it into this envelope by encrypting it, and sends it over to the bank. The bank takes a pen, signs, makes a cryptographic signature, and sends this so-called blinded signature back to Alice. Alice can now decrypt it. Alice is the only one that can decrypt it because they have encrypted it before, and takes out this now signed secret. So we have now a signature of something that the bank has never seen. This is the money. So this construction here where you have the secret and the signature together is eCash. This is what is equivalent to these money icons that I'm using in the talk. Now, when you come back later and you want to verify this and talk back to the mint, you basically just send it back, and then the mint checks the signature and says, okay, this is actually worth something. Now, really give you an impression of what is going on here on a data level. Here's an example data structure, very simple what this looks like. So you have the secret that is a random string, and if you encrypt it, you create this blinded secret, so to speak, that you can send to the mint signs it, the blinded signature is that, so still this JSON with this C underscore here. And then when you send it back to the user can then decrypt this C underscore to the C, that is now the blinded signature, and the secret, the original one that the mint has never seen. This is the money. So this data structure is what you see when you see the string encoded, for example. So some of you might think, wait, this is not secure because there is an amount value here. I could just change the amount, right, and then make my token worth more than it actually is. You can easily prevent that by giving any amount that the mint supports a special private key that the mint used to sign that, right? So you can make sure that no one can mess with the amount actually. But now, when you listen carefully, you might probably think, wait, this is bad because this is not good for privacy. If you make any amount with their own private key, you might be able to correlate things. For example, if I mint a token that is worth 325,426 satoshis, very specific, very rare amount, right? If I mint that amount with a special private key and then send it around, and then someone comes back with this 374,000 whatever token, the mint will have a very easy time to correlate these two things, these two events, right? It will probably be the token that I've minted 2 days ago or something. So in order to prevent that, any eCash system usually limits the number of values that it supports. So in Cashu we have just amounts that are 2 to the power of n. So 1 Satoshi, 2 Satoshi, 4, 8, 16, and so on. And using this, you can combine any amount, basically. If you want to send 420 Satoshis, you just build it up out of these building blocks. So what I've showed so far is the basic principle of how eCash works. If you got that, you basically got how eCash works. I want to take it to the next level now by adding spending conditions and scripts to these tokens. So very similar to what we are used to in Bitcoin with the UTXO mechanism, basically. In Bitcoin, when you receive UTXOs, you actually lock them to a locking script. And when you spend them, you unlock the Bitcoin again, basically. And you can do the same thing with Cashu tokens or eCash, what I call programmable eCash. So one example that we have already built is pay-to-script hash. Very similar to how Bitcoin works. It actually uses Bitcoin script itself. So here the flow a little bit changes. Instead of now Alice generating a random secret and locking eCash tokens to it, Carol, the receiver, now actually generates this secret, which is not secret anymore. What she generates is a lock script, as you might know also from the Bitcoin blockchain, and generates a script hash from that is now an address. People say address, actually it's not an address, it's a lock. And that looks here like this green icon that you see here, that is the lock. And that also is equivalent to this address, what people call address. Now you can take this address, or a lock, you can send it to anyone and say, hey, send me some Bitcoin to that lock. Right, what does it mean? Now Alice takes out eCash from her database, her wallet, and puts that lock onto that eCash. Now this eCash is locked to something that only Carol can unlock. Sends over this thing, and now Carol, to finalize this transaction, very similar to what was done before, needs to send it back to the mint. Then the mint says, wait, there is a script attached to that eCash token. I want to see the script, please. And now Carol provides the unlocking script. Objective is very similar what most Bitcoin pay-to-script hash transactions are on the blockchain. Checks the signature, everything is okay. Removes the lock, generates a new token, and sends it back, and the transaction is complete. So what you can do with this construction, for example, is semi-offline receiving of tokens where you know these tokens that I just received will only be unlockable by me, for example. But you can do many interesting things once you introduce scripting to the whole system. One example I want to give is a user to use a Lightning bridge. Basically, you can lock, for example, now we have Alice, she has an eCash wallet, and we have Carol. Carol has a Lightning node. And Alice wants to make a Lightning payment, but she doesn't have a Lightning node. What she can do is ask Carol, hey, can you make this Lightning payment for me? And in exchange, I will give you some eCash tokens, maybe with a little bit of fee. And these eCash tokens will only be unlockable once you present the proof that you have made the Lightning payment using a pre-image, right? So, but a lot more is possible. You can do time locks, atomic swaps with other things, multisig, whatever you pleases you, basically. Also HTLCs, I think this is very interesting. You can have a hash lock and a time lock in a script that makes an HTLC and other sorts of smart contracts. So I've alluded a little bit on how this might work with Lightning. What actually already works is how you get these tokens and how a mint can provide you with Lightning services, so we can make Lightning wallets out of eCash systems. So in order to describe this, I'm just going to present to you the two atomic or two base operations on Lightning, which is first one, receive an invoice, right? So you want to receive money on the Lightning network and get eCash for that. What you basically do is, Alice now again the user, the mint says, hey Alice, pay this Lightning invoice. If you pay that Lightning invoice, I will give you tokens in return. Alice makes a Lightning payment using any Lightning wallet she has, gets eCash in return. So also referring back to the first talk today, this is how you can exchange through a payment on the Lightning network, can generate eCash and exchange that for that. The opposite of that is paying a Lightning invoice, what I call melting a token. Basically here the roles are just simply reversed. Now Alice asked the mint, who has a Lightning node, can you please pay this Lightning invoice for me, and in exchange I will provide you eCash tokens. And the mint pays this invoice and takes and then destroys this token in order to take it out of circulation, because the balance of the mint decreased. All right, so this is how the interaction with the Lightning network works. I also want to show you how you can integrate Cashu into existing projects. This is kind of the idea, so that we can maybe transition many of the systems that we have already into a Chaumian system. And one example here is the Cashu integration into LMBits. If you don't know LMBits is fantastic software that you can run on your own Lightning node, basically to supercharge it and give it all sorts of capabilities, generate infinite number of wallets, and have lots of different extensions that you can use. And one of these extensions now is Cashu, so you'll be able to, with a couple of clicks, basically become a Chaumian mint yourself. So if you have LMBits running, it will be probably literally 3 clicks and you're a Chaumian mint, and you can then provide these services that I've just explained to your users, to your family, to whoever. So this also comes with a web interface that runs as a progressive web app on your phone or on your desktop. It really feels kind of slick and has all sorts of basically all the Lightning capabilities that you need executed the way that I just explained. So I invite you to check it out. I've set up a demo instance just for the participants of the conference here. You can go to cashu.space. This runs on mainnet, so be very, very cautious and don't be reckless. But you know, maybe you'll pay a coffee or something with it, but remember to take off your money again. You can go to cashu.space, open it in your browser. The tokens that I was just talking about, they will literally be in your browser, so you will host them. It's kind of a bare instrument. And again, I hope you had fun, and thank you for listening.
Thank you, Calle. We have some time for questions, have we?
Let's go.
Anybody wants to have a question? Anybody has tried this already? I think Jan Paul, you tried this, of course. Our friend from Spain has used it. And how was the experience? No? How was the experience?
Nice.
We get some live user feedback here. Huh?
I've been testing it since the very beginning with Calle, and it's amazing. And the last iteration, this one that we saw in the last screen, that you can use on the phone, it minds, your brain explodes when you try it, because it's very easy, and it's a technology from 1982. No, this is an eCash system from Chong, so it's great. It's really great.
Perfect, yeah. The mind explodes. That's somebody else already told me this. So try it out. And Calle, you're going to be around. And anybody who wants to have like a one-on-one, I think you're very welcome to discuss.
Definitely.
And we have another masked supercoder coming up. And yes, we're going to the next talk. I think if there's one thing what you can say positively about lockdowns and everything, it has become normalized to walk around with a mask and be a shadow supercoder there. All right. Okay, we have some time. Yeah, we still have 10 minutes. It's terrible. If you like make two Germans run the show here, it's okay. Yes. So, like I said earlier, like these Xiaomi